When faced with a problem, we can frequently use math to solve it. One of the most powerful tools is to employ something called mathematical modeling. And what this means is that if we can identify what kind of math is going on in a situation, we can model that situation as a mathematical equation and then use the power of algebra to solve. So some examples of mathematical models, if we recognize that something is a linear relationship, we could use the equation of a line, y equals mx plus b. If we recognize that something is a percentage problem, we can use part equals percentage times base. Sometimes it's neither of these, and we just need to draw a picture and put one unknown in reference to some others. Sometimes we have a system of equations with multiple unknowns if it's a more complicated problem and there's more going on. And there's some other mathematical models too that we'll get to later in this course. In all of these, we have to recognize what type of math is going on. If you're faced with a quadratic equation, you don't want to use a linear model. You also have to identify what information plugs in where. For example, if you're working with a linear model, you want to know what the rate is. You also want to see how the information is applied and if all of the numbers have a part to play. Let's go through these steps with this problem right here. Let's say you moved across town and rented a 20-foot moving truck for the day. You wanted to make sure the bill that you got checks out. If you paid $81.03, for how many miles were you charged? And we're assuming no fees for the sake of this problem. So this is information that I copied from the U-Haul website. And I see that there's a $39.95 flat fee for renting this 20-foot truck. And they also charge 79 cents per mile. So is this a linear equation? Is this a quadratic equation? Should we draw a picture? Thinking about this, we have an initial fee, and then we have a rate. I know it's a rate because it's in dollars per miles. This is a linear equation. I'm going to use y equals mx plus b, which is the equation for a line, a linear equation. I also want to define my variables. So we're trying to figure out how many miles we were charged. So I'm going to say let m equal mileage. I don't think I spelled that right. I could also use x. And now I have to identify the pertinent information. The 20-foot moving truck has to do with which one I selected from the menu, but I kind of cut out the other options. Other pieces of information that matter, the total amount of bill, and then the $39.95 flat fee and the 79 cents per mile. So let's put all of that into an equation. So the total amount was this $81.03. What this equals is the mileage, the rate, times the number of miles. So each mile is another 79 cents. So if I drove 10 miles, that would be $7.90. If I drove 100 miles, it would be $79. So each mile driven increases that number. So it's 79 cents per mile. And then we also have our initial value, our flat fee. Even if we drive only, if we drive 0 miles, we're still going to get charged almost $40. 39.95. This is in the form of y equals mx plus b. The m is our slope, which is our rate, which is 79 cents per mile. And b is the initial value, which is that $39.95. It's charged even if x is 0. even if the mileage is 0. To solve this equation, we first subtract $39.95 on both sides. End up with 41.08 equals 0.79 m. Divide both sides by 0.79. And we will end up with exactly 52 equals m. So look how long it took us to kind of talk through this problem and set up this problem. As soon as we got here to this step, this was our translation step. As soon as we got to this translation step, most of the work was done. Solving the equation was pretty easy. We still have one last step, and that is to check and make sure that this answer makes sense, and also to properly state this answer. So we were asked, how many miles were we charged? Our answer is 52 miles. Does this make sense? Does it sound reasonable for being charged $81? Yes, I think so, for the prices given. So this mathematical model followed the equation of a line. So what do we know about slope, and what do we know about y-intercept? The slope is the rate of change. So it has to do with the speed something's changing. It's the ratio. In the U-Haul problem, it was 79 cents per miles driven. It's a speed. The y-intercept is the initial value or the starting point. So in the case of the U-Haul problem, the y-intercept was that $39.95. We actually could have sketched a quick graph with the y-axis being the dollars and the x-axis being the mileage, and it would start up here at 40. This is a terrible graph. And then per every mile driven, it would go up by 79 cents. So our line, probably not even that steep. Our line would look something like that. It's a linear equation.